So what you see on the screen is the evolution to software-defined data center. And you see there's quite a lot going on. What we want to do is pay attention specifically to the complexity in the wide area network. And it's what I talked about in the very first slide. So we have here, we have an internet connectivity where we don't have all the internet services shown, but we know that we're connected to the internet, and we've probably got VPNs, cloud services, public cloud, software as a service, infrastructure as a service, depending on the size of your organization and the maturity. We may also have public services. So for example, in the UK, councils and government services, they have actual services which are publicly consumed over the internet or private internet, if you catch my drift. So it will be like you have to be certified in order to get this type of internet-based connection into a government platform type of thing. And it's not a VPN, it's normally like a private MPLS type network. And then I've just put another one in there as an example. The next one is we have a cloud, but it's like if you're doing a data center migration or a software-defined data center upgrade, you might be just upgrading what you've got in place at the data center that you're actually located at. Or you might be going from a single data center, which is a server room in your office, to a completely re-architected design. So you might be going to two separate co-location facilities, or you might go to one co-location facility plus AWS or Azure or whatever. So I've got the legacy data center in there as if it's a completely separate entity that you're migrating from. We've also then got below that the wide area network. So this is where your actual remote sites connect, and then they ingress into your data center, where what we were only really going to talk about in this whole presentation, if you were to take it at face value, which was never my intention, but what we would normally just be talking about are these spine leaf topologies. In regards to ACI, you would have your APIC clusters, and then this is your orchestration tool, which would be multi-site orchestrator, for example. And then we have a whole load of other things like firewalls, load balancers, firewalls at both sites, out-of-band management switches, and all that kind of thing. So why is this a software-defined data center? We've got another couple of slides after this that will explain the underlay and the overlay, but to keep it high level in the interests of time, why is this a software-defined data center? So we have a couple of different additional components involved here, and those additional components are what I highlighted there, and I'm just going to focus in on them for the time being. So that we've got the APIC cluster in data center 2 and the APIC cluster in data center 1. My pen didn't work there, but there it is. And then we've got the fabric or the spine leaf in data center 1 and data center 2. PC's decided to go slow, but we'll get there. And then also the multi-site orchestrator. So how does this fit together, right? The APIC here basically is used to configure the spine leaf switches here. The APIC cluster here is used to configure the ACI cluster here, or the fabric cluster here. And until multi-site orchestrator, which is this platform in the middle, was developed, you had to basically manage them as two completely separate entities, from a configuration perspective. So a multi-site orchestrator provides you the ability to push certain configurations out across both sites, but there is still certain things that you need to do in the APIC, I believe. One of the other things that is relevant to talk about here is we're in a old school data center design like this, for example. You'd probably have an address here, and a HSRP address, which is the default gateway the servers would use. But that would normally be hosted on the distribution layer switch and be the ingress egress from the data center. So the first point of layer 3 that a server would hit would be on the distribution or the core in the data center, whatever you wanted to call it. But that big chassis-based Nexus 7K. In software-defined data center, what we do is, or what we have is, we have an Anycast gateway. So let's just say we have subnet 10, and the default gateway is 10.10.10.1. So 10.10.10.1, and if it's across both data centers, is basically available on every single one of these switches, which is relevant. And that's basically a difference in the solution. So basically what happens is if we have a server on this switch down in the bottom right, and it's trying to talk to this server, and you're connected to the same switch, it'll broadcast out and then just talk to the switch like that. If this server here, which is red, and I'll just change the color so that it's a bit easier to see, wants to talk to this green server here, but let's say it's on the same subnet, it sends a broadcast out, but it realizes that it's not on the same switch, but it knows from the spine that basically via EVPN, which we'll talk about in a minute, that in order to talk to this server on the same subnet, it needs to go across to the other fabric and down like this. So basically you can have the same subnet in different locations. You have the same default gateway for every server on the same subnet. But let's actually say that communication was there. You can also, with micro-segmentation, and this is where software-defined data center excels, you can actually put a policy in place to say, well, actually, although you're on the same subnet, I'm not going to let you talk. Well, I'm not going to let you talk to that server over there, because in my policy, you're a web server and he's a Active Directory info that you're trying to have isn't allowed. So this is where you start building up the picture of like the evolution from the ship, purely chassis based, lots of ports, plug anything in everywhere and can all talk to each other, to spine leaf, a bit more structured. You might have like firewall security zones for different parts of the network, to single point of control with the, you know, this box in the middle here, via the APIC clusters, and you can go down to the host level and stop them speaking to each other. So this is where a software-defined data center really like starts coming into its own. In addition to that, like you can also do things like, you know, when you provision a certain type of network, so let's say it's a web network, that's sort of like profiled so that you know when you deploy a network for application type 1, that application type 1, we only used to ever think about like, well, it needs a VLAN and it needs a subnet and it needs a default gateway and it needs routing. But what you can do now is you can say, well, in addition to that, actually deploy a server load balancer, which is configured with this profile, And in addition to that, as well as the server load balancer, ensure that it isn't able to talk. Host 1 is allowed to talk to host 2, 3, and 4, but it's not allowed to talk to hosts 5, 6, and 7 on the same subnet. So that's where the policy side of things comes into play.